Okay, so we talked about how to graph these exponential growth functions and how to make that XY table. Now let's apply it to a real life situation. Okay, where this is used in real life is to study trends in data. For example, right here, where we would use this is you would have an exponential growth model that stuff and data would go into. Okay, so it kind of says up here, this is an excerpt right from your book, if you need to see this kind of in front of you, but it's the same thing as your book. So when a real life quantity increases by a fixed percent, kind of goes through and explains that. I'm not going to read that. But basic thing that you guys are going to need to know is to be able to use this formula in different situations. Okay, don't worry about having it memorized or not. I want you to focus on how to use it. So when I have this formula, the variables obviously represent different things. Okay, y represents the amount of your quantity that's increasing. Okay, so we're going to say y represents your quantity after it increases. So for example, if you're studying how, I know that they use this for science to study how bacteria can grow in a certain mixture. Y would represent the amount of bacteria that you ended up with after a certain amount of time. A represents your starting amount. So for the science example, that would end up being the starting amount of bacteria. Okay, so A represents your starting amount. And R actually represents the rate at which your amount is increasing. But remember, you're going to have a percent of increase, but we never want to put a percent into our problem. So that's going to be our percent increase. But we have to be careful. We need to use it as a decimal. Okay? And lastly, your t is going to represent your time, but it's always in years. Okay, so that is the equation or the exponential growth model kind of taken apart. Now let's use it in a real life problem. This problem is example 4 in your textbook.